Example 2, checkpoint 1, which is another example of this using the map, okay? So using the map on page 300, the pyramid of the sun is 1.1 centimeters in measurements. Okay, the sides are 1.1. What is its actual dimensions? Okay, continuing to use what we know. 1 centimeter is 200. They've told us this. If I measure the pyramid of the sun, it's 1 1/10 centimeters. What I want to know is how many meters that is. Most of you will cross multiply and find that the value of x equals 220, which means the dimensions of the shape is 220 meters by 220 because the base of the pyramid is a square. Okay? So far so good? Okay. Brussels, Belgium does this event every couple of years where in their large town square they fill it with flowers. They don't just fill it with flowers willy-nilly though, they actually make decisions what they want to put where. They create a scaled drawing of what they want. Okay, so this is example 2. I'm going to just show you what maybe it might look like. Okay, so let's just say this is my square. Okay, and maybe I want my chart to just be, oh my word, that doesn't look anything like a tulip. Okay, so I want the squares design to be super, super simple. I just want it to be one big giant tulip. Okay, so this is the scale drawing I have drawn of the town square of Kankakee, and this is what I want. This is going to be red, this is going to be green, and the background is going to be a blue sky, whatever. Okay, the scale for this is, we're going to say that each box is 1 centimeter. Okay, that's what we're going to say. So each box, I'm going to say 1 centimeter. We're going to just pretend. And the city square is actually 400 meters in width. Okay, the city square is actually 400 meters in width. No. Well, let's just make it an easier number. Let's say 1 centimeter is, yeah, we'll do it that way, 100 meters. Is that the same thing they did last time? No, it's not. So that would work. That'd be about, okay. So that would mean the actual width of Kankakee Town Square is 400 meters wide and 500 meters long. Okay, you know the place where they do the farmer's market? Okay, maybe that's the place I'm going to do. Okay, based on this information, if I asked you approximately how wide is the tulip at its widest? Approximately, given that I am not a master artist. Well, you might say, it looks like it's about 1, 2, 3.5 centimeters. Would you agree with me? Based on all the lies I've told you about how wonderful this is? So 3.5 centimeters. So how wide is it at its widest point? It's 3.5 centimeters. So then that I want to know when I go to the farmer's market, how wide is that location actually going to be? They're going to do this. They're going to draw this. They're going to chart it out. So you're going to discover that x is equivalent to 3.5 times 100, which is what? 350 meters. Okay? 350 meters. So that's exactly what they're doing here in the floral carpet example that you have in your book. Okay? Theirs is a lot prettier than mine. Their scaled drawing will ascertain what they want to put where. Suppose the carpet itself is 40 meters wide, and the designer creates a scale drawing that is 20 centimeters wide. Okay, so their scale drawing is 20 centimeters wide, and the width of the carpet itself, the real flowers, is 40 meters wide. Okay, this is the scale of the relationship between the real drawing and the real carpet. But if you were going to tell me the scale, you would not tell me this. You would reduce this and end up with 1 centimeter equals 2 meters. Okay, cut off your zeros, reduce 2/4. This is reduced. Okay, the scale of your drawing is 1 centimeter is 2 meters. Okay, now here's an interesting factoid, and they kind of show you this below. I have indicated my units here to be sure that you understand that this is centimeters and this is meters. They're not the same unit type. Okay? However, if you wish for your unit type to not be in question, you can actually adjust it so that they're the same unit type. Okay? I would still leave my thing centimeters and then convert 2 meters to centimeters, which would look like this. Now I have a scale representation that is irrelevant as far as units are concerned. Okay? 1 of whatever equals 200 of whatever. That is the legitimate scale explanation without units. Now in the real world, you're going to want probably this because you're thinking to yourself, well, wait, how big is this thing? Okay, but to explain to someone that 1 to 200 is the scale, that is accurate. Okay, because that would assume the same unit type. Okay, space shuttle. This goes back to, like I said, my model airplane days. A model of a space shuttle has a scale. This is example 3 of 1 to 52. 1 to 52. The space shuttle has a wingspan of 78 feet. Okay, so 1 to 52. Notice they didn't give us unit type. Okay, so 1 in the model is equal to 52 of the real deal. Okay, what did they tell us is 78? The shuttle or the model? The shuttle's wings. So I'm going to put that down here. It has to match with the real because that's what we're talking about. So then if the real space shuttle's wingspan is 78 feet, how long is the model's wingspan? Set up exactly the same. 78 times 1 is equal to 52x. So 78 divided by 52 will give you your answer. 1.5? Is that what you guys came up with? Good. X is equal to 1.5. Okay. Now,
can I trace 2b to the Jensen? Trace 2b?
Notice how they told us feet here. They told us feet here. So what is this? This is feet as well. Okay. When they tell you unit type, and in the original they did not, that means these both must have the same unit type because these also had same unit type. Okay? All right. We could do the same scenario with checkpoint 2 if we want to. I'm going to do that real quick. That's the last item today. Checkpoint 2 says the length of the space shuttle is 122. Find the length of the scale model in example 3. Okay, so we've got the same scenario. Model is 1, actual is 52. Okay? The length of the space shuttle is 122, so we have to put that where it matches with actual. Model's on top, actual's on the bottom. Okay? Model is what we want, and by the way, they told us feet here, so this is also going to end up in feet once we're done. 52x equals 122. What'd you guys end up with? To the nearest tenth. To the nearest tenth. 2.3, perfect. You guys are doing great. 2.3 is exactly right. Okay? That's everything you ever wanted to know about scale drawings, and with this information, there's a lot you can do. If you want to take a drawing, some of you guys that like to draw, and you see something really, really big, and you want to shrink it down to your sheet of paper, you can ascertain the dimensions of the big thing. That way you shrink it properly on your piece of paper. Or in contrast, you can flip it and you can make something bigger. If you see something tiny, you want to draw it bigger, okay? You're already doing that naturally with your eye if you're good at art, but if you want to be exact and accurate, scaling is